Okay, before we start, thank you very much for Nine for having me and giving me the opportunity to give a talk today and for organizing the meetup and bringing us all together. That's really great. Thank you. So today I want to talk about a tester toolkit. That's a toolkit I have built myself over 15 years as a test engineer and software engineer. And I want to share a little bit about that and also like why it came to be to navigate complex software systems. A little bit about myself. I have over 15 years experience as test and software engineer. I have worked in e-commerce, banking, taxation, security. So I had a lot of fun with the talk. Thank you very much. And also public transport. And all of that was product development. So working on long-living products and software services that accumulated a lot of features and capabilities and history over time. And this is also where this complexity comes from. And also like projects, they end and product development never ends. They always continues except they fail. But this is something we don't want to happen. Yeah. So complex software systems. So when I want to talk about how to navigate complex software systems, we need a common understanding of what complex software systems are and how they originate. And let's start with an example from the real world and the difference between simple and easy, because simple and easy are different things. For example, you write a letter to a person. Before we had instant messaging, you would write a letter, you would take a pen, you would take a sheet of paper, would write something on it, would put it in an envelope, and you would bring it to the letterbox, and someone would bring it to the person that it's supposed to receive. So there are a lot of manual steps, a lot of things you have to do. This was simple, but in comparison to today, it was hard. It was more hard than just grabbing the phone, open an app, typing something into the chat, and pressing send. But by making this process more easy, we introduce more complexity into it. So this is a little bit of how I see it and also how other things see it. So if we have simple things, they are hard, but if we have complex things, when we make things more easier, they get more complex. There's also a talk by Rick Hickey, really great, I recommend it. He talks, the whole talk is about that and in the context of software development. So take a look. So what are some things that make our software complex? And like when we are in a very specific business domain with a lot of different requirements, acceptance criteria, use cases, and a domain that's not for everyone. Like instant messaging, every one of us knows how this works. But like taxation or security, this is more specialized, and there are less people who know how this works and how it's supposed to work. And it takes more time and more effort to learn about it, really good at it. Also long history, like I've worked on software products that have a history of over 10 years. That doesn't mean they are legacy. They have always been like worked on and new technologies have been adapted and introduced. But this also means there's a lot of knowledge that's accumulated over a long period of time. There were a lot of decisions that were made and there were reasons for that decisions. And it's always interesting to know why was something decided in a certain way in the past when we make new decisions or look at something. Things that have many dependencies, like other services, or when many different technologies are involved, like when we look at infrastructure and we have applications that run on Java and other applications that run with Go. Then we have single page applications, it's done with JavaScript and TypeScript. So if you're working with a system like that with a lot of different technologies, they all have their own quirks and things you have to take care of, and their own are their own things and need their own knowledge. Things that are highly configurable I've worked on an identity and access management with over thousands of properties that you can configure. And a lot of things can go wrong. You can introduce security risk with that. And when you think about the impact of new features or changes, you always have to think about these properties on what might change or influence each other. And this is also complexity. And of course, things that are big, like big systems with a lot of applications and services running, or consisting of many modules, all of that together brings a lot of complexity. And what are the challenges with such complex systems? Like when you sit in a refinement, in a meeting, in a workshop, and you talk to each other and you think about a change or a new feature, to think about all these things, all these complex things, all these little things that matter, and think like, okay, what's the impact when we introduce this change to the other parts of the system, to the other parts of the software? Maybe something can break, maybe something gets insecure, and it's really hard in complex systems to think about that. Also, and the same applies not only when you do impact analysis or workshops, also code reviews. When you review the code and you think about the data flow and what happens if you change something within this data flow, what happens to what comes after the change in the code, right? And also it's hard to remember the history, to remember what we have decided last year and why we have decided that. And is this still a good decision, or maybe the circumstances has changed and it's not a good decision anymore? And also in complex system, it's hard to get a common understanding, because just because I say something doesn't mean the other person understands the same that I have in mind. And it also doesn't mean that the person agrees with what I've said. Maybe it has another mental model about the system, another understanding, and we have to work on that to get a common understanding and work together on a solution with that common understanding. Also, like thinking critically, as engineers, we love to build stuff. We love to be proud of what we do, but sometimes it's hard to get another perspective, the perspective of someone who thinks more critical about what we build and how it will be perceived by users, or how it can be operated by operations, or how it can be maintained and understood by other people. This is something that's really hard, because we are focusing on trying to solve problems, and it needs another perspective that looks into this solution, because they were not involved into trying to solve a problem, and think critical about that and point out problems and flaws that exist. And also, so this is something I personally feel like every day when I work, I want to strive for like a constant standard of excellence. I want to do a good job, but like there are things outside of our job. There's life, and life is also complex and hard, and sometimes easy and sometimes not. But when we have a toolkit that supports us in what we do and what we work on, then we make an opportunity to be more consistent in the quality we deliver. So my opinion is, and what I believe, we can master complex systems, but it requires a lot of discipline and structure, and like knowing how to do it, and always coming back to these structures, methods to do so. And I will show you some of these tools that give structure, that help you to manage your knowledge. But the discipline is something I cannot show you. This is something everybody has like to work on, me myself as well. Sometimes I also forget to look at these structured methods, to look at what I've built, and then I come back to it and be like, yeah, I should have looked at that. So yeah, some examples from the toolkit, and it's built on principles. And one of the principles is like continuous growth and continuous learning about the business we are working for, about the users. This can be the end users, this can also be internal users that work in operations, about the people that operate our software, about technical aspects like the architecture, the programming language, infrastructure, the software product itself and its capabilities, or the service that we provide for others. Also exploration and observation, like experimenting with the software, getting into a perspective of a user and interacting with the software and see how it behaves and why it behaves like that. And checking, like, for example, the logs and see what is happening, why were certain decisions be made, and what data did I give the software that it made this decision. And like getting really deep understanding about the product or service. Critical thinking and questioning, like being critical of our own work and the work of others. And this doesn't, it's not meant in a bad way, like you do a bad job. It just means in a way to make solutions better and find problems earlier. Knowledge management, like there's a lot of knowledge around about the software, about the development process, and you cannot all keep that in your head. You have to write it down to have it in place, and you have to constantly keep it up to date, and so you can come back to it, and that is that you can rely on that. That's a good source of what is true and what's not. Continuous improvement, like improving the development process, improving the way we work by ourselves. And transparency, like being honest about the state of our service or product, being honest about what we know and what we don't know, what we assume. I think these are really good and important principles if we want to work with the toolkit. And the very first tool are questionnaires. A questionnaire is just a list of questions that you can go to and ask yourself or other people. And every questionnaire is like about a specific topic that you want to question or gather information about, or maybe help to get a common understanding with everyone involved. And this questionnaire can help you to discover problems or to know what you assume, and what you don't know, what information is missing. And then you can look for that and figure it out, make an analysis, maybe ask someone who knows it, and so on. I have two examples for these questionnaires. So I have one for onboarding. When I get into a new software project, then I have a list of 45 questions that helps me with my onboarding and get to know as much as possible on a high level about the project, about the things that matter. And one of the questions is, what are the roles within the project, and what are your touch points? So what is my role, and what touch points do I have with other people? Who are the project's customers or stakeholders, and what are their challenges? So like, we are building software products and services for people. They have challenges and problems, and our software is meant to help them with their problems. So if we want to develop good software, we need to understand what their problems and challenges are, so our software can solve it. What are the most complex or error-prone areas of the system? So this is something to look out for when you like test it or work on that. And how does incident management work? Like when you are on call and there's an incident, who gets involved? What are the dashboards to look at? How is the infrastructure working? How can a bug fix be deployed? How can a rollback be made? All of that information. And it's also important, like, to know what are your options when you publish a release and you discover you missed an important error. What are your options? Can you roll back? Can you only go forward with a bug fix? And this can help you to mitigate risks. I also have a questionnaire like for new features or changes with 36 questions, 26, and 3 of them are what are the users and business impact if this feature doesn't work? Like, are the people blocked? Is there a workaround if it's not work? Is the feature not important at all? And 89% of the people will not notice it because they don't use it. This is important information. Also, what test data do I need to test it when I implement it, or when I'm a test engineer and want to test it, or for test automation, do I need a specific test setup? And then I can already start preparing this test data and test setup in parallel to the implementation. And this saves time. And also, what kind of metrics should be created? Should there be new dashboards, new metrics that we want to look at? Is there any metric that says this new feature is successful or this new feature fails? Things like that. So what are the use cases for these questionnaires? These were only 2 examples, but one is like for refinements, or when you create requirements, you can have specific questionnaires for these activities and go through them and think about them critically with the help of these questions. Also impact analysis, like when you think about your architecture and a new module, a new component, a new service within this architecture, what's the impact of that? Or when you think about user journeys and you change something on that user journey, how does that impact the existing user journey and the user? Technical solution designs like diagrams and flows, data flows. Reviews, any kind of reviews. If you review the work of somebody else, you can use the questionnaire that helps you with the review and come up with good ideas and critical questions. Testing, like coming up with new test ideas, and planning and task breakdown, like think critical about the plan you are making. I mean, plans always change because something unexpected happens, and that's okay. But if you take your time to make a plan, then make it worthwhile. The next toolkit is about people, because as I said, I think we make software for people to solve their problems. It's a lot of fun. It's also a lot about technical aspects, but in the end, if you want to have a successful software, it needs to solve real problems and it needs to serve the people. And sometimes that gets, in all the tech talk and all the discussions we have about technical solutions, that gets forgotten. So these are personas. Like a persona is a person that has unique characteristics, like or a specific perspective on something. And you can have a list of personas, and each of them has another perspective or another requirement or another thing they do with the software product you are building. And this helps you to think about like their behavior, their expectations they have for the software, and also the problems they have, and how you think your software will solve those problems. For example, there can be many personas from identity and access management, like the end users, the people who want to log in and access an application. They want to reset their password when they forget about it. They want to do session management, like their sessions they have on their laptop, on their mobile phone, on another laptop. They want to decide how to authenticate with a password, with a second factor, with passkeys, with all these different things. And then there's like the administrator who does user management. He needs to understand what roles the user has, what's access. He wants to edit this access. Also, like help when he gets a call from a user, like I cannot log in or I don't have access to this application. Can you help me to get this? And support the end users. And also like operations, the people you give your software to operate, like on-premise, for example. They need to integrate it in their infrastructure. They need to observe this with good logs and metrics and observability. And they also need like to maintain it, to update it, to do database updates and stuff like that. And it doesn't stop there. There are also like developers, people who want to develop clients for the REST API of the identity and access management. products. They want to build custom single-page applications that use this API. Maybe they even want to customize and extend it to give it more capabilities. And there are also people within your own organization that build this identity and access management. For example, the customer support who gets calls and Jira tickets with problems. And so you need really good logs that the customer can attach to it, so you can understand what is the configuration, how did the system behave, what exactly is the problem, and you can help them. Otherwise, if you don't have that, it's really hard and costs a lot of money and time and effort to help them. And also maybe they want to coach the customers. They want to have documentation on how the product works and use it. And maybe you even have customer service who does the integration for the customer. And have even more capabilities to customize and extend this. So a lot of times personas are used for end users, but I think it's a missed opportunity to also think about the people inside your organization that work on the product and are relying on certain things there. So what I want to say is, like, consider not only the end users, but also the other people your software has an impact on. Good. So another tool, another example, like in cartography, the Earth is geographically big and complex, right? And there were explorers, and they used cartography to document their understanding of the Earth. And it wasn't always right. There are funny maps about how they thought the Earth looks like, but over time it improved and got better and better. And today we are still using maps, and they still help us to navigate the complex geography. And we can do something similar with software and features and components. And this is what I call feature maps. Like, you can create a mental model of a feature. It doesn't have to be a feature. It depends on how big it is and how complex. It can also be a single functionality. It can be a component, a module. I think everybody has another. You have to feel comfortable when you look at the feature map. It doesn't have to overwhelm you. You have to feel comfortable, and it needs to help you with what you want to do. And this creating the feature map helps you to gather information, to get an understanding of the feature in a structured way. And then after you have created it, you can come back to it, for example, impact analysis, or think about dependencies. And this way you make opportunities to see problems or things you are missing. Here's an example, like this is Gmail, the dialog to create a new email, right? I think a lot of you have seen that, and it looks really simple. But if you map that to what it can do, to its capabilities, you end up with something like that. And this is what I call a feature map. It's like a mind map with different groups and their capabilities. And it shows how much functionality is hidden behind other dialogues and pop-ups and things you don't see immediately. And I have used Gmail for many years, and I didn't know about most of these functionalities until I created this feature map. So it really helps to get deep into a feature and learn about it. And it gives you a structured approach because you know what you have already covered, what you have already discovered and created, and what not. And if we zoom into that, we can have a closer look and see, like, okay, there are many formatting options. There are different ways to handle attachments, like from Google Drive as an attachment or as a link, to handle images also as an attachment or inline within the email. You can also upload attachments from the hard disk. So if you discuss something about the attachments, you can have a quick look on that, and you know immediately what the product already can do. And then you can think about, how does this new idea, this new change fits into that? And I think this is really helpful. And it gets much faster and easier to do that than to open the application and discover it again and again, what it can do and what it cannot do. Because you don't need test data for that, and you don't need to bring it in certain states. You can just look at it and it immediately brings value to you. And it also helps like to build a common understanding, because if you show this to someone or you create them in a group, in a workshop, you all look at that and have the same ideas, same understanding also of the terms and words you're using. Because sometimes you use terms and 3 people understand 3 different things about them. Yeah, also some examples without concrete data, but these are real ones I created. They don't have to live in isolation. They are also like links that link to business rules, so they can live in your existing documentation. And you can also map like processes. This is like a really long, complex e-commerce process to buy tickets. And every box represents a screen and its capabilities, what you can do on each screen. So this really helped to understand what this process can do, what you have to test, what data you need, and the different states that you can up with. There are more tools, but these are just the ones I found most interesting. There are like cheat sheets that you can look at, like for example for test ideas, cheat sheets to test mobile applications, to test web applications, and that spark ideas to generate test ideas and do testing. There's also like a structured approach to note-taking and journaling that helps you to sit in a meeting and write down notes in an efficient and structured way, so you can look back at it a week later and say, okay, we discussed this, this, and this. We had these open questions. We still need answers, or I found answers, and here they are. Also risk management, thinking about risk, discovering risk, and decide how to mitigate them. Continuous improvement, how to improve the development process, how to make it more efficient, faster, or to collaborate more, to have more different perspectives, how to fasten feedback loops, and also like exploration and design, like before you implement an idea, what ways you have to learn about it, because sometimes something is so big and complex that that it's faster to just start implementing and prototyping or build a proof of concept instead of talking for days and weeks about it and make solution designs. Sometimes it's faster and more efficient to start. So, and of course, we cannot talk about all of this without talking about AI. Why is this still important, and why I think this still helps even with AI at hand? I think AI will increase complexity of software systems, and also the software development process itself. We will integrate AI agents and conversational agents into the existing systems, and we will create more tools that enable AI agents to do certain things. And I think all of that increase complexity of our software systems. And I think AI benefits from structured, tailored knowledge bases and methods like context, WAG, all of that. And all of what I have showed you today are knowledge bases, is context that you can give the AI, are structured methods and processes you can give to the AI to do certain things, and that helps them to do good work in your context, because they have learned based on a lot of information, but your context, your domain is unique, and it needs to know what is unique about it. And also, like what I discovered over the years, it's not like a tester's toolkit for software testing. I think it's more like a product development toolkit, because it helps in every role. I've also worked in software engineering, I still do, and I still use this toolkit even if I'm not a software tester at the moment. That's all. Thank you very much. If you have any questions, feel free to ask me.
So we're a bit short in time, but maybe one question? Or everyone is hungry already, so let's continue.